a slightly more extended amount of time discussing that. The main problems, actually, question one, I think most people were fine with it, which is good because that's the important thing. So just to quickly go over it, everybody, it seems, has understood the rules decently. So okay, so in question one, everything was just using the rules, which, just to remind you, is a to the m times a to the n. The base numbers have to be the same. Is given by a to the sum of the powers. There were some negative powers, so the definition is 1 over a to the n, right? So the minus sign indicates a reciprocal, or it's flipped over. It does not mean that the number is negative, right? So that's a common mistake to make. But just because there's a minus sign in the power does not mean that the number is negative. Okay, so everything was just using those and your fractions kind of knowledge. So the very first one, hopefully you can see that it should be 2 to the power of 7, which is 128. So either way, it's either form is fine. If you wrote 2 to the 7 or 128, it's okay. Next one is pretty similar. The base numbers are all the same, so you can again add as you normally do. So it's minus 3 plus 5 minus 1. So that's 2 minus 1, which is 1. So it's just 5. 4 cubed over 4, hopefully. So I guess there's two ways to do it. You can write out the entire thing if you want, in which case the top becomes 4 times 4 times 4 divided by 4, and you cancel, divide by 4, so you have 4 squared, 16. Or you can convert the bottom into power. So 4 cubed over 4 is the same as 4 cubed times a quarter. And remember how our negative powers are defined. It's 1 over a to the n. So this is 1 over 4 to the 1. So this is the same as 4 cubed times 4 to the minus 1. So this is 3 plus 1, so it's 4 squared again. Okay, next one, 2 to the 7 over 2. So same idea as before. 7 minus 2 is 5. So as long as you're dividing with the same base numbers, it's worth it to know the rule that x to the m over x to the n is equal to x to the m minus n. Okay, so just to recap, I think everybody did fine on this, but just recapping. So yeah, for part E, you can do the numerator and the denominator separately. So at the top you have 3 squared, at the bottom you have 3 cubed. And 3 squared divided by 3 cubed, that's of course 1 over 3. Okay, next one, you have to be careful. The bases are not all the same. So I guess you can look at 2 to the 5 and 2 to the minus 3 first. So that becomes 2 cubed times 3 squared times 2 minus 3. So this is the same. Remember, the order of multiplication does not matter. So it's 2 to the minus 3 times 3 squared. You look at this first. Of course, you have 2 squared times 3 squared. And if you want, you can be fancy and do 2 times 3 squared. This is 6 squared, so it's 36. But 4 times 9 is also okay. Right. Okay, next one, again, similar kind of idea. It's best to join up all the bases that are the same. So 5 and 5, 2 and 2, and 3 is by itself. And doing that, you see that it's supposed to be 5 to the 1, 2 minus 1, times 2 to the 4 minus 2, so 2 squared, times 3 to the minus 1. So this is, of course, 5 times 2 squared times 3 to the minus 1. So you can't do any more. You can't add the powers because the bases are not the same. So it's 5 times 4 times a third. So this is, 20 times a third, which is 20 over 3. If you want, you can express it as a mixed fraction. So 6 2/3. Okay. Right. Last one. The last two questions were the rules that we learned last class. So it's when you have a power of a power, you multiply the power. So it's 3 times 5 is 15. And when you have power of a product. It's the product of the powers, right? So by that I mean ab to the power of n is the product of the individual powers. So here it's 2 cubed times x cubed. So the answer should be 8x cubed. Okay, so like I said, in general, most people did fine here, so that was encouraging to see. The next one is a bit trickier because the questions were not as standard. So if you found this difficult, don't worry, that was the intention. But everything that the answers here all depend on basically everything, the question one, the skills involved in the question one. So the skills involved are the same, just use it in a different way. Okay, right, so let me ask Satya, what did you get for A?
I think I got it wrong, but
Okay,
with
but
the
can you
first
tell me
one
what
being like one, so for minus 3 to the power of minus 2 or something along the lines of 1 over minus 3 to the power of 2, which is 9, so 1 over 9.
Yes, that's right.
Then it's minus 1/2.
Yeah, so this is 1 over minus 2 to the power of 1, which is just, yeah, you're right, minus a half.
And then 1.
Yeah, this is just 1.
And then 0.
Yeah.
1.
Mm-hmm.
Then 8.
Yeah.
Then 81.
Okay, right. Yeah, and then what did you do next?
I think I just added them together, but I got it wrong.
I think okay, let's do it. Let's see how you did. So yeah, it's easiest to add the fractions and the whole number separately, right?
Yeah.
So if you add up all these numbers, then you so ignoring the fractions for now, the whole numbers, what do they add up to?
91.
Uh, 90, so that's 89, 90, 91. Yeah, so okay. So 91, yeah. Ignore that. Okay, and then so we have to do the fractions. How would you add the fractions?
Oh, could you just have a common denominator? 18.
Yeah, so what does 1 over 9 turn into in the half?
2 over 18 and 9 over minus 18.
Minus 9 over 18. Yeah, okay. Yeah, and then?
Oh, just minus 7 over 18.
Yeah, okay. Right, so everything we can group together and okay, so minus 7 over 18. That's our so our final thing is 91 minus 7 over 18. So we just gotta do that. So yeah, it's gonna be a bit tricky, I guess, because the numbers involved are kind of big. But this is right? So if you work this out, it should be the right answer. So if you want, you can save yourself some trouble by separating the 90 into 90 plus 91 into 90 plus 1, right? So I mean, you don't want to do 91 times 18. So what you do is this is 90 plus 1 minus 7 over 18, right? This one you can do easily. So what is that? The second part. Satya, I'm still asking you.
Sorry,
this part, the fraction.
11?
Yeah,
Or what? 11 over 18.
Yeah, right. So it's 18 over 18 minus 7 over 18. So it's 11 over 18. And 11 over 18. So how would you express this answer finally? Would you leave it as that, or would you express it as something else?
Well, you could write it as 90 and then remove the plus.
Right. So this is just a mixed number, right? So this is 90, 11 over 18. Yeah. Okay. Yeah, that's fine. If that's what you did, then you are correct. Now, again, because you're at home, obviously you can't do this in the exam or anything, but all these answers you can definitely check by directly putting it in the calculator, right? So this is for everyone. You can check, that your answer is correct by literally just putting in these numbers one by one in your calculator, or even online and seeing what the answer is. And if you got the same, then you know that you're correct. Okay, so yeah, the answer here was 90, 11 over 18. I think a lot of people made some mistakes with the minus signs. I think that was the main thing. So yeah, you do have to be careful. So my suggestion is that don't skip steps. Do it one by one if you're not sure. So minus 3 to the minus 2 is 1 over minus 3 squared. And then the negative number does not matter for a square, so it's 1 over 9. Right? So you have to be careful. Do it step by step. Okay, so here the answer is given as 1631 over 18, but you can write it as a mixed number also. Okay, part B. Okay, Bebe, can you explain what the difference between these two powers are?
I got it wrong. So
Okay, well, you can still. So what did you say originally? You thought they were the same?
no, I didn't know what the first one was. I just didn't know.
Okay, well, if I put a bracket here, does that make it easier to understand?
Is it? I don't know.
So what is okay? Maybe I should explain. This is 2 to the power of 3, which is, but the 3 is raised to a power of 4.
Oh, that makes more sense.
Right. So if I put a bracket here, what is 3 to the 4? Do you know?
I don't know on the top of my head.
Okay, you can separate it, right? 3 to the power of 4 into two simpler powers.
81.
Yeah, so either you can do 3 squared times 3 squared, which is 9 times 9, or 27 times 3, but that might be harder. So yeah, 81. So 2 to the power of 3 to the power of 4 is 2 to the power of 81. Okay, so compare that with this. Simplifying to this, what does that become? 2 cubed to the power of 4.
2 to the power of 12, sorry.
12, yeah. So which one's bigger?
The first one.
Yeah, and that's way bigger, right? The power is way higher than to the power of 15. Okay, right, so that is the main difference. So yeah, this question was a bit problematic for a lot of people, and I guess it's entirely down to the fact that they hadn't seen something like this before. Not quite. I think I did mention it in class though. So yeah, and you know, it doesn't have to stop here. You can literally go on forever. 4 to the power of 5 to the power of 6 to the power of 7 to the power of 8 to the power of 9, blah blah blah, right? These numbers are going to increase very, 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 very quickly. Okay, right. So again, in general, here the BIDMAS or PEMDAS or whatever you learned in school still holds. I for indices, that's the first thing you do, right? So here the indices is, or the index is 3 to the power of 4, which is to the power of 81.